Okay, so we'll start making that tower defense that I showed you, but we'll do it for PC and single player. So I already have my engine opened, and first of all, let me show you that I organized the folder. So I have a folder for sprites, for scripts, for so it's organized, and I also prepared some sprites, so basically images for the game. And the first thing that I have to tell you about this is that this is URP, Universal Render Pipeline, meaning you have lighting in this uh, type of uh, game, which for the moment we don't really need. But first of all, let's rename this scene. So we call it level 1 because we have different maps. And the first thing we have to actually draw the map. So to do that, we need a couple of things. First, we need to find the tiles. So we have here ground, and we have to split this image into multiple sprites. So to do that, we go here. First thing first, when you're working with pixel art, we need to change the filter mode here to point. Because these here basically combine pixels to make the image look smoother, but with pixels art you want to see every pixel, so we don't use any filter. And then we open the sprite editor, and let's see. I believe it's we can slice it by a certain size, so by cell size. I see that I'm lucky, it's already 64 times 64. So now we have the tiles. Let's make a folder. Never mind, I already have it here. So we'll create a tile map to the tile. Sorry, not tile map. Tile palette. So this is rectangular because each tile is in the shape of a rectangle. So create one, call it tiles. I have to open it. Wait. Yes, here we have to place our sprites for the ground. We just simply drag and drop everything in here into this. But why is this? Okay. See, now we have the tiles here. And we need to create in the hierarchy tile map. So 2D tile map, rectangular, and now we can draw with this in the scene. But before that, let's make sure that these are the right size, because you see if I wait, see this is not this does not cover one tile, because in the settings, so here in assets, this needs to be 64 pixels per unit. So the size of the tile, the real size of the tile. And now you see, now it covers the whole you know, the whole tile. Okay, so let's see. Also, if you have any questions, stop me at any time.
Okay.
Now there is a tool here. You can draw this individually like this, or you can use this tool to just create a square like this. Oh, sorry, rectangle, not square. Make it a little bit a little bigger than the camera view. And now we want to create the how do you call it, path of the enemies. But before that, let's make some platforms for um, the turrets. But I actually want to make another. Oh wait. Yes, let's make another tile map here. We'll call this one Okay, we'll call this ground 1, we'll duplicate it and call this ground 2. And we want this to be one layer above this one. So if this is this is 0, then we want this to be 1, so above it.
Okay.
And now we will draw. See here in the tile palette, you can select which tile map you want to draw on.
Okay.
But let me see if I did this correctly, because yes, it's not correctly. You have to go back to this one and delete everything, because wait, I don't know what's happening. Wait, I'll remake it. Sorry.
Mm.
Okay, so this one is ground 1. Ground 2 above it. Let's do that again. Sorry, it has to be ground 1. Sorry. Yes, ground 1. And then above it, ground 2 is a ground 2. And let's see, we want in the game this is 5 by 3. So 1, 2,
Mm-hmm.
3, 4. Wait. So I did it by mistake. Let's see how long this is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18. So 18 minus 5 is 13. So 1, 2, 3, 4, 5, 6. Let's see, 1, 2, 3, 4. Actually, let's we'll just start deleting one by one until we have 5.
Mm. Okay.
Okay, so now we have 5 and they are centered. And these on these the turrets will be placed. So it's 5 by 3 like this.
Mm-hmm.
But now we need to draw the corners.
Mm. Okay.
We'll do that.
So you had created all these individual clip art or clip files already?
Nope, these are from the internet. They're not mine,
Okay.
but they are free to use.
Cool.
So we add the corners, and now the edges as well. We need to add them, but I don't see which one it is. Here like this. And this one here. Something's missing from here, I believe. See, I don't have this part here, and I don't know why. Let's see if we selected everything. What? I don't know. Do you see it? I don't see it.
Mm. Yeah, I don't see it either.
Let me see that. Maybe I missed something here in the editor. No, they should be here.
Mm.
They should be, but they're not for
Mm.
some reason.
It's weird.
Yes, maybe I did not select everything inside here.
Mm.
Okay, let me see. Yes, we missed a couple.
Mm. So you just downloaded like a sprite pack off the internet somewhere, like a free sprite pack?
Yep.
Okay.
Oh, and this one. That's what we need.
Mm.
Oh, it already exists. Well, I replace it. Guess.
Hmm.
All right. Now we can draw this.
Mm-hmm.
Okay, so will be this will be a space for the turrets. And now let's make the path for the enemies.
Mm.
So we want the ground 2, which is above the grass. And in the game, it is something like this. Uh, yes, something like this. Okay.
Mm-hmm.
And we just add the edges. And uh, so that one there, this one. Nope, not like this. This is very confusing because they are not in order.
Mm.
And I think we might be, no, never mind. So here we want this. Yes, and now we just need this corner here.
Mm-hmm.
Oh, this one. Okay.
Nice.
So now we have the level, and we can start coding. We want first I'll start with the enemies and then the turrets. So for the enemies, let's find some sprites for our first enemy.
Okay.
Okay. See what this looks like. It is blurry because of the settings.
Mm.
So let's start with this one.
All
So we need a sprite renderer. So we'll create a sprite. We'll rename this to the name of our master, in this case daemon. We'll add first. Let's select what animations we need. We only need two: the idle and the walk animations. So we have to select every frame of the animation. And first, let's in pixel per unit. Let's find the size of this sprite. 24 times 24. So here we'll add. We'll change this to 24 for everyone, every sprite. And also here in the sprite mode, multiple means there are multiple sprites. These are one sprite each. So we'll change this to a single. And the filter
Mm-hmm.
mode to point. And to see it here, we add one frame of the animation to our sprite renderer. But you see, it is below the grass because of the order. In layer here, we
Mm-hmm.
change this to one above the second layer of grass. So two. Now it's above.
Mm-hmm.
Okay. And let's see what we need. We need a collider, so projectiles can interact with this. So box collider 2D. It's not the correct size. We have to resize it ourselves. Something like this. Um, Yes, and now let's see. We want here is trigger, so no physics for this, and we want a rigid body so we can move this character. Dynamic, I don't know. Dynamic, maybe kinematic, meaning only it only moves by script. Since we don't have physics, so we don't really need this to interact with other uh, colliders. So kinematic, we move it by script, and constraints. Let's freeze that rotation, just in case we don't have physics, but just in case. Okay, and we can start coding. So for this, we will have two scripts. One script will contain everything that these enemies have in common. And then if we want some extra behavior, we'll make a separate script for that.
Mm-hmm.
Uh, but for this, we also need an animator, so the animations. And I created a folder for this. We need the animator controller, which is a tool for managing animations.
Mm-hmm.
Okay, and now let's create those two animations. So the idle first. So animations, call this demon. Let's call it run. And then we drag, and actually this has to be in the animation folder, not here. Okay, and we drag all frames here. Let's see how it looks like. Too many frames per second. But wait, this is not run. This is the idle. Sorry. This is not the. Have to add the frame from here from run. So 24 pixels. Single. No filter. And now we can drag this here. But why is it like? Oh, I see. My bad. So it seems that we have two animations. One for walking to the left, and one for walking to the right. We only need this one, and we have to slow it. So this value here, samples, means the speed of the animation. Looks okay.
That's cool. Yeah.
Now we do the same for the idle animation. Create it, and we drag all sprites here from the idle. I don't know why they made two animations for, because we can actually flip the sprites inside Unity.
Mm-hmm.
Okay, and now we need to create some transitions. So here in the animator, we have these two animations, and by default it is run, which is okay. We want this to be the default one, but we want to make transitions from run to idle and from idle to run. And the condition for this transition will be a parameter here, a bool, which we'll call is running. And here on the transition, so from run to idle, heads exit time. This here is a setting for 3D games where you want to combine two animations. So when you transition from one animation to the other, when the transition happens, it combines the animation, both animations, so the transition is smooth. But for 2D, we don't need this. And the condition should be is running is true. Sorry, it's false because we auto idle. And from idle to run, this is true. So is running is true. Now created the transitions. And now we need a script for all enemies. So let's go to our script folder, create new mono behavior. I will call this enemy. Now we have we need to wait a second for
Mm.
the editor to create it. Okay, and now we will add this script to our object in the scene.
Okay.
And let's see what we need here. I actually have a script from another game here for the background. We'll create some a background effect with this later.
Mm-hmm.
But now for the enemy, we need a couple of things. We need the components. So the components meaning this here in the inspectors, the sprite render. Actually, we don't need everything. We need the sprite, the rigid body, and the animator. That's it. So here we'll get these components. So sprite renderer, animator, and body 2D. And in the start function, so this function happens at the start of the existence of the object, but in this case, at the start of the scene, we get all of these components from the object. So with this function, you get the component from with this type from the current object that has this script. And let's copy paste this for the other two. So the animator. Okay, so now we have all these components. So let's comment this components. Components. And now we need some stats for the enemy. So public means you can see it in the inspector and it can be accessed from other scripts. So max HP we want. So this one is arranged max HP. Then we want the current HP. So HP. We want some move speed. This one can be float. And I think that's it for now. Um, and we want a starting direction. So in which direction this enemy moves when it spawns. So for that we create a vector tree here. And we call this starting direction. And here at the start we want to make this enemy move towards that direction. So but since we're working with 2D rigid body, we don't need a vector 3. We need just a vector 2 for this, just 2 dimensions. So here we say move enemy on start. So rigid body velocity, linear velocity, changed it, and then the starting direction times the movement speed. So we have the direction and the speed. Okay, and now we want to make sure that this enemy changes direction when it reaches uh, the corners. So
Mm-hmm.
for that we'll create some colliders that will change the direction of this enemy. So for that, let's create an empty object. Call this change direction collider. We'll add a box collider 2D to it. Trigger, since we don't need physics. And let's see. Guess we put it. We have to experiment with this actually.
Mm-hmm.
But I'm thinking because these enemies will have different sizes, and I don't know how to where exactly to place this.
Mm-hmm.
Okay, I think we'll do it another way. Okay,
Mm-hmm.
we'll do it like this. We'll create an empty object for the enemy, and then this will be main. We call this main. Add it as a child. Sorry.
Mm-hmm.
Okay, and we do this because we want one collider to be for projectiles, and for that actually let's create a tag here. We call this enemy and add that to our object with the collider, so we know that this collider is enemy. And then we want to place a collider at the feet of this enemy, so that it will change direction with that. So here we create an empty object called feet collider, box collider 2D, trigger, so no physics, and we need to resize it to the fit of this, or something like this. Um, and maybe we don't need we don't need wait, actually never mind, we do need um a script on this collider that will change the direction so that we know in which direction to go. So for that we'll create a script. So scripting mono behavior, we call it the same, change direction collider, and this one will simply have a um, vector 2 direction, and this one is public so you can see it, and that's it. Only need this one here. And here we want a script for this fit collider, so that when this collides with the change direction collider, it will change direction. For that we'll create a script as well. Call it enemy fit collider, and inside we just want um, the on trigger enter 2D. So this everything you put inside here happens when you touch a collider that is trigger and it is 2D. So here we want to have a category for that change direction collider.
Mm-hmm.
So we create a tag for that, change direction collider, and that's we also want a reference to that rigid body here. So rigid body 2D B, and in the start function, so we want the rigid body to have the rigid body so we can change the speed. Okay, and on trigger we check if this is the dot collider, so collision dot compare start. So we want to see if the object that we collided with is that change collider. So here we check if it is change collider. Okay. Yeah, collider. And if it is, then we want to find which direction of that script. So rigid body is equal, sorry, rigid body linear velocity is equal to that direction. So we want to get the script. change direction collider like this. So you get that script, and then the direction. But the problem we have here is that we don't know the speed. So to fix that, instead of getting the rigid body, we'll get the enemy script here. Enemy script, because that script has the rigid body and also the move speed. So we'll get the whole enemy script like this. And here we can now multiply, but not the rigid body. So the rigid body from that script like this. But it is inaccessible due to its protection level because we made it private. So we have to go here, and here at the rigid body we add public, so now we can access it. And you'll see this changing here. And now we multiply this direction times the move speed. So enemy script move speed, and that's it. Uh, let's see. Yes, this one we have to change its type collider. And let's see where we place it. We'll have to experiment with this. Place it something like this. And yes, we need to add the script to it. So collider, change direction collider, and now the direction we want this to move to the right. So on X1 basically, and we'll duplicate this collider to the other corner, and we want this to move down. So 0 on the X and -1 on the Y. Okay, and let's select our demon and enemy, and here let's give it some move speed. Have to experiment with this as well, and start in direction. We want this to be 1 on the Y, and the HP and max HP are 0, but here in the script we can, the start function, set the HP to max HP, so we don't have to modify both values. We can just modify the max HP.
So basically, depending on which type of character and how strong they are, that's their max HP.
Yes. We'll also have bosses in this game that have special effects, like changing the type of the turrets, or decreasing your turret level, stuff like that.
Yeah, yeah, that's cool.
But we have a problem. We need to the animations. Actually, never mind it. At the moment, we don't need anything, but at some point, we'll have the ability to stun enemies. In that case, we want to change the animation from run to idle, but we don't need this right now. Let's see. The fit collider has. Does it have a script? Nope. We have to add this to our fit collider. Okay, let's see if this works first of all. But so place this here. Sorry, the whole object. This. But when we change direction, we want to make sure that the sprite is flipped correctly. So to do that, well, the problem is sometimes some sprites might be flipped the other way around. So some sprites might be flipped to the right, some might be flipped to the left. So to correct this, we want to know which direction the sprites are by default. So we need a bool. So bool sprite direction. So if it is false, if it is true, then it is to the left, and if it's false, it's to the right. And let's see, here at the beginning, we want to move it here. And here, if we're moving to the left or right, we want to flip that spread accordingly. So here we check if that starting direction x is different than 0. So meaning we're moving to the left or the right. Then we want to see, let's see. So if sprite renderer flip x, so with this property you can flip it on to the right or the left. And let's see, if this sprite here is false, then it is to the left.
Mm.
But I have to think about this 1 second. So first, let's see if this starting direction here is bigger than 0. So if we are moving to the right,
Mm-hmm.
uh, and let's see, this is it's complicated. We need two cases here. We want one if this direction, if sprite direction is false, it is to the left
Mm-hmm.
by default. So inside this we put the, if you are moving to the right basically, then this need to be flipped here. So sprite render flip x is equal to true. We flip it because it is by default to the left, and we're moving to the right. And else, so if we're moving to the other side, we want this to be false. And it is complicated because we want this to work for any sprite regardless of its default orientation. And here we say else. So if that sprite detection is true, meaning by default it looks to the right, we'll copy this, but we'll reverse these flip like this. But let me see. Let's create actually a function for this because we might want to check this from other scripts. So let me delete this update. Void, we call this flip sprite, and we need to know the linear velocity. So instead of looking at the direction, we look at the velocity of the rigid body. So instead, we'll check the velocity instead of the, not for some reason, yes. So the velocity x. Like this. And now we can copy all this stuff here.
Mm.
We copy it and put it here. Because we might want to do this from other, when we change direction. So here we'll say fix sprite, flip sprite, and then in our change direction, enemy fit collider. So when we change direction, we also want to say um, after we set the velocity, we flip the sprite like this. But you see it is red because we forgot to say public, so we can access it. Okay. The editor is bugged a little bit. You see that here? I don't know why,
Mm.
but seems to work. And it's time now. It's time to test and see if this works.
Mm-hmm.
And I will change this right here so it looks to the right.
Mm. Okay.
Let's see if this works. All right. Yep, seems to work, but it did not collide.
Mm.
First thing first, let's see if that's let's reduce that speed a little bit. That's a bit too fast.
Mm-hmm.
Okay, and let's see. Yes, the problem is this kinematic needs to be dynamic, unfortunately,
Mm.
so we can interact with colliders. And here we'll change the gravity scale to 0 so that it has no gravity. And the mass doesn't matter because it doesn't interact with anything anyway.
Mm-hmm.
And now it should collide with that and change direction. But we need to make sure that it collides with the feet, not the whole collider. And it does not collide, as you can see.
Mm-hmm.
And let's see why that is. First, let's see. This is trigger. That's good. Um, that fit collider. Maybe this should have a rigid body. I don't know. I'll try that.
Mm.
Rigid body 2D and static reversed. Maybe that is the issue. There are some conditions for these collisions because there are different type of collisions. So you can have a trigger with trigger, triggered without trigger. You have different types of collisions and they have some conditions, but I'm not sure why this is not happening. So let's go to our fit collider here and let's debug and see if this happens here. Say collision happen. So make sure that this happens first. Now we should see a message here in the console. Oh, what was that? Yes, yeah, that happened because of the fit collider with the other collider.
Mm.
So let's see if it happens again. It does not. So that means, yes, I see the issue. I see the issue. The issue is that these are not on the same Z value. For some reason, this was we had a random value here on the Z. So let's see first if it works without a rigid body. We don't want extra components. We don't need them.
Mm.
Okay, so that's okay.
Well, according to that, it says collision happened.
Yes, but that it happens only once when the game starts because of this fit collider here collides with the other collider.
Mm. Okay. Gotcha.
Maybe we need a rigid body. I don't know. This is very odd behavior.
Mm.
I'll try to make this dynamic and reduce the gravity here. Let's see.
Mm.
Okay, did not happen again. Okay, let's look at a couple of things. So first thing, we need to make sure that this collider is on zero on Z. It is. Um. Oh, I see what is. Um. I think it might be because this does not have a rigid body. Maybe we do it another way. I don't know if I can have two rigid bodies actually straight up zero. Maybe that works. This usually doesn't happen, so I'm not sure exactly what the issue is.
Mm.
Yeah, it still did not happen.
Hmm.
So let's look at the direction. The direction is correct. 1 on the X, and here -1 on the Y. Uh, this is very odd behavior. This is trigger, okay. Dynamic, that should be good. Feed collider. Okay, this is 2D here. Um, this is odd because this should say collision happened regardless of this if, because this is before the. So we know that the tag is not the problem.
Mm-hmm.
Time to figure out what the issue is. Okay, let's look on the internet, I guess. Let's see. Unity figure with trigger collision. How to manage collision of two triggers? Let's see. Collider remove collision. Make two triggers. And I think I might be lagging. Can you hear me?
Yeah, I can hear you.
Yeah, I'm lagging a little bit. Sorry about that. Okay, let's see. We have some conditions that we need to look over. So let's see. Trigger message and information. Turn on to triggers collide. Was that project? I don't know. Let's see. After triggers, well, ability to have a kinematic rigid body on at least one of the triggers. I don't know if that's correct.
Mm-hmm.
Let's try it. I'm not sure if it. So at least one of them has to have a rigid body. Let's put one of these. Rigid body 2D. So at least one has to have a rigid body. Uh, okay, we'll do it another way. We'll just make this physics-based collision, and we'll make this physics-based instead. Here we'll set this to uh, yes, uh, not trigger, and instead of using on trigger, and then we'll use. Actually, let's comment this in case we need to return to this on collision. Enter to the. We'll copy this. So collision dot collider in this case, and here collision dot collider, and now this is physics based. See if that works. There are some conditions for different interactions.
So basically, all we're trying to do is just to have that collide with, when it collides with that object, it will turn to the right, basically, right?
Yes, and you can see that it still does not work, even though we use. Um, yes, maybe it is because it's not dynamic. Now we're using collision based. So sorry, not collision, physics based collisions instead of triggers. Still does not work. Okay, let's see. I'll remove the rigid body from here and add it to our feet instead. So let's make sure that is no rotation. Yes, just no rotation. And actually should also change this. Okay, let's pause 1 second and look at this.
Looked like it hesitated for a second.
Oh, I see what the issue is. Uh, you see, we have a problem here. The problem is this collider does not move with the object force. Ah, I see what the issue is. I see.
So the collider has to move with the object for it to collide with the other collider.
So that the problem is, unfortunately, we'll have to do it another way, not like this. Okay, because this moves without the feed collider. The feed collider remains here at the starting position. Okay, so instead we'll do it like this. We'll call this the name. Remove that unparent. And now we want 2 layers for this. So we'll create the fit collider as a child. Box collider 2D. And we can maintain trigger actually because I think that was the issue. So now we need to resize this, add the script, and then change those colliders again. And we'll have to add some layers, physics layers, so we can disable some interactions. So it's trigger, so without physics. And then we want the fit collider script, resize this. Okay, something like this. And let's change this back to trigger. And now maybe if we change this to collision, no, not work. Yes, we unfortunately need some layers here. So for these two, we'll create another layer. We'll call this change a direction collider. Um, or actually, yes, and then fit enemy fit collider. So this here and this one here, and we want for the dim the uh, collider that will receive projectiles. We want to just call this enemy, just enemy, and now we can disable these interactions here in settings. In physics 2D, we'll disable all. Now we'll enable only the ones that we need. So we want um, change direction with um, enemy fit collider like this.
Mm-hmm.
Um, and that's it for the moment. So just the change direction with the enemy collider, enemy fit collider, and now it should work because the main collider and the interaction between the main collider and the change direction collider are is disabled. And now you see we have an error here. Let's see
Mm-hmm.
why that is. So it's a null reference. So something here is null, so it does not exist. Let's see the exact line of this. So this line here. Yes, the problem is uh, collider. So first thing, this enemy script should yes, that is the problem. This enemy script here is null because we are looking for it on this object, but we actually have to look for it on the parent object. So here instead we need to say transform parent get component like this. So we want the component from the parent, not this fit collider. And let me know how much time you have free because uh, we discussed already
Yeah, I got a little bit more time. Kind of want to see how this turns out. You know, like getting it to do the collision. So,
so see now it works.
oh, there we go. Nice.
And we have a wait that one is not positioned well. So let's go to
Hmm.
reposition
Oh, I see. Oh, okay.
something like this. And uh, this is not correctly. You don't have the corner here on the tile map.
Hmm.
So let's
Oh,
go
yeah.
to tile palette and find that corner. Yes, like this. No, it's correct. And we can create. Actually, I'll have to look for some UI because we need um, somewhere to see how many lives we have. So when the enemy, if you don't kill the enemy so safely and it reaches the end of the path, you lose one heart. We need some
Okay.
UI for that. Um, but I think we can find that quite fast. They should be here on the
Mm.
page. This is a great. This is great for 2D assets. So let's go to assets. We just need a heart. Support. Yep, we have a bunch of options.
Mm-hmm.
I'll use this one. Okay.
So you can literally just create assets and sell them as a like a way to make money.
I guess yes, we can create
Mm,
both 2D or 3D for
I
money.
see.
I'm not an artist. I just program as a hobby.
Mm-hmm. I gotcha.
Okay, now we just drag and drop this here. We'll make a new folder. Actually, we do have a folder here with UI. I missed that, unfortunately. Let's take this
Mm,
anyway. So now let's create some UI for yes, some UI. First, we need a canvas.
mm-hmm.
Then we need to make sure that it is scaling with screen size, so it adapts to all different resolutions. Reference resolutions. Use Full HD, and inside we place it somewhere at the top here near the camera. And let's see those this was not a help bar, just let me see this. Yeah, we just need this. Okay, so um, here in the canvas we create the UI for that. We need first let's go to that canvas, double click on it. So this one is the canvas, and we want an empty object. Um, call this hearts. How do you call? Yes, hearts holder or yeah, holder. Resize this a little bit. Uh, maybe in the yes, in the top left, like this. And we'll use something called horizontal layout group. So we can place those hearts at equal distances. And for that, we'll create those hearts. So empty object. This one will be. So we want two images. One when you don't have the heart, and one when you have the heart. So we call
Mm,
this heart, and inside this we place those two images. So UI image. This one will be empty. So we'll say empty heart. We'll copy this and call this full heart. And the image. Let's add this. And we want to preserve aspect also. And now we can duplicate this how many times we want. So in the original game you have three lives like this. And here in the horizontal layout group, we want this to not expand like this first. And also we need to resize this a little bit like this. Maybe add some padding. Uh, from like this, so that it is centered. Maybe even uh, decrease the size of this a little bit, something like this.
mm,
Okay,
mm-hmm.
and now we can place anchors. So anchors means with this you place. This helps to adapt it to different resolutions.
Mm,
So it will always be in the same place with the same size. If I do this, place the anchors
okay.
in the corners on all resolutions. Let's see if we can disable the full heart. Yes, so we can disable this and see the empty image. Now, um, we need a script for the
So basically, oh,
Yes.
Oh, I was gonna say, the animation for the heart disappearing is whenever the enemy goes to the basically makes it through.
Yes. When the enemy makes it through, you lose one HP.
Yeah. Okay.
And now we'll have to create a script that will name a game manager. So this will handle the spawn of the monsters, losing HP, changing scenes, even spawning turrets, combining turrets, stuff like that. So we call this game manager, and we'll make an empty object that will hold this script. Uh, and for now, I guess we'll just create a loose condition. So when three enemies pass through and the game starts, we can transition to the main menu. So first, we create an empty object. We call this game manager. Tag the script on it. Go to the top so we know you can see it clearly. We need a couple of things. So first thing we want to say using Unity engine.ui and also using Unity engine scene management, so many we can change scenes. We have the public int level, so we know which level this is. Um, and then let's say here UI stuff. Um, yes. So first thing we want to for that uh, public int parts. Okay. So we call this number hearts actually, and by default here in the start we say yes. We say or actually let's just do it in the inspectors. So for the UI we need an array with those images. Uh, so the red heart we need an array with those, so we can disable those
Mm-hmm.
when we lose health, and they need to be actually they need to be in order. So for that we need public game object um, red heart um, UI. That's hearts. Alright. And we can do something here interesting. We can um, yes, we can do something interesting, which is we'll place this game manager instead, because we need to know when the enemy collides with the end of the path, and to do
Mm-hmm.
that we can get connect the game manager to that enemy script, but that means we have to do that for every enemy. So instead we'll do this just once by placing the game manager here at the end with a collider. So instead of enemies checking
Mm-hmm.
for the game manager, the game manager checks for enemies. We just hit the box
Mm-hmm.
collider 2D, reposition it a little bit like this, and here we can say yes on trigger enter 2D. We want to check if it is an enemy. So collision compare back enemy, and we also want a bool here to make sure that when the game is over, we don't we don't check for collisions anymore. Public bool game over. Okay. And here we want to do a couple of things. Um, yes. So if it's an enemy, then number hearts minus minus, first of all. And excuse me one
Mm-hmm.
second. Be right back. 1 second.
Mm-hmm.
Okay, sorry about that. I'm back. Are you here?
Oh, you're fine. Actually, do probably need to get out here at the top of the hour in a few minutes. So if we can find maybe a place to kind of stop for now.
All right, we can stop now. No problem. And
Okay,
if you want,
cool.
we can continue tomorrow for an hour or two at about this time.
Okay.
Okay.
Yeah, yeah, that'd be good.
Just let me know
All right.
as early as possible, please, because for me
Yeah.
it's very late now. Okay.
Okay.
All right.
All right. Well, thanks for your time, man. I appreciate it.
No problem. No problem. See you.
All right. See you later.